So, today we will discuss about basic analysis in laboratory. So, I have discussed about the data collection procedure in the laboratory. So, today I will discuss about the graph plotting. So, after taking data, we have to extract information from that data. So, this it is easy way to interpret or to extract information from those data is basically plotting graph. Okay. So, I will discuss about the plotting graph using the data obtained in laboratory. So, what are the types of graph? When you plot graph, which types of graph we are plotting, that we should know. So, basically there are three types of graph. One is line graph, another is I think bar graph, and third type is pie graph or circle graph, also you tell circle graph. So, line graph basically it is mainly we will use line graph. I will discuss about the line graph. So, here basically we represent the variation of an variable with respect to other variable. So, in that case this we use line graph, and bar graph it is a use for comparison. Okay. So, I will discuss about the line graph in details. So, just let me briefly tell about the bar graph and this pie graph. So, this bar graph is used for comparison. So, if we have data, so we can say size of the particles, you have a material which are having different size of particles. Okay. So, huge number of particles. Now, what is the size variation if you want to study? So, generally we make it group that okay, 0 to 10 say nanometer size particle, 10 to 20, 20 to 30 nanometer, 30 to 40 nanometer. Okay. So, this way we group this particle size instead of considering each size of the particle. So, we consider the size of the particle in groups. So, this is one example. Second example, in a class, what is there are many students. So, how many number of students are there? So, basically we plot count versus this some parameter, it can be age and it can be particle size. Okay. So, how many particles are there in this group 0 to 10 or 10 to 20 nanometer, or how many students are there who are having age between say 10 to 15 or 15 to 20. Okay. So, this for comparison, so we make group, age group or particle size group. Now, then we count and that we plot as along the y axis this count. Okay. So, this is basically bar diagram, we represent with the bar diagram x axis and y axis, x and y. So, in along the x axis, so we have grouped it 0 to 10, it can be age or particle size as I told 10, 20, 30, 40, 50, 60 like this. Okay. So, then we are plotting here counts, it may be number of particles or it may be number of students. So, then we count it and then what is the number? Now, this you have to make scale, say this is 100, this is 200. So, we have to scale it, this 300 like this. Okay. Now, if you see this within this 0 to 10, there is no particles within this size, fine. 10 to 20, there are say 150 particle. So, this 150 particle. So, generally we represent with this bar, and then between 20 to 30 we see that say 400 particle. So, then we represent like this. 30 to 40, it is a 100 number of particles. Okay. So, this way we represent. So, it is easy to compare this this way. So, between 20 to 30, this graph is showing that it is the maximum number of particles within this 20 to 30 nanometer, or number of students are there or pupils are there within this age 20 to 30. Okay. So, for comparison it is very easy to represent. So, there are many examples. So, what is your income or your family income in different years. Okay. So, this x axis you will scale it or level it as a year, and y axis you will represent with this your income, that rupees per year, in rupees per year. Okay. So, then you can plot it and then you can see the variation of the income in different years. Okay. So, this is basically bar graph, and pie chart or pie graph, it is basically, if you want to, this is used for representing a portion of a quantity. Okay. So, as for example, say what is the in atmosphere in air, what are the elements are there and how much they are. So, in air this composition is basically nitrogen gas, you know this, around 78%. Oxygen gas, it is around say 21%, and this other gas, argon and this other gas, it is around 1%. Okay. So, you are representing the different components in air. So, different components in portion. So, these are the parts, portion, component. Okay. So, how much it is? So, if you want to represent that one, so this type of things, it is easy to represent with this pie graph. Okay. So, that is basically circle, you take a circle, this represent the whole year. Okay. Now, you are just total area you are dividing with this percentage. So, 70% area we will use for representing nitrogen, 21% area will use to represent oxygen, and others we will use the area 1% area we will use. So, the total is 100. So, then I think you can just divide the area. So, this portion of area is this portion of area you can mark. Okay. So, basically this is just mark it. Generally we use color, different color. Okay. So, this portion is representing nitrogen, and say this portion is used for, it is a 21% area of the. Okay. Okay. This portion is for oxygen, and this other part basically this part. Okay. So, this part is 1%. So, this others. Okay. So, this is the pie chart. Okay. So, now I will discuss about the line graph. This mainly in our laboratory we use line graph. Okay. Although these other things we use, but mostly we use this line graph. So, I will discuss about the line graph in details. Okay. So, line graph. So, how to plot line graph in on a graph paper. So, I have shown one graph paper here, one graph paper here. So, you are quite familiar, but nowadays we are using computer, this graphics, there are very good graphics to plot graph, but this manual plotting is important to learn what I am doing. So, to learn that one is very important to learn manually, and after learning you use graphics, computer graphics for plotting graph, that is fine, but manually we should learn how we are plotting graph, how computer is plotting graph. So, that we will understand. So, this is a graph paper, standard graph paper. So, graph paper generally is a small box, square box. Okay. So, it has, each box has length and it is a width, right. So, this we take as a this length here is a, so this box. So, here this one is a bigger box, right, this one is a bigger box, inside again this small box are there. So, we have to consider this each box. Okay. We have to scale this each box with your data, it is in different units. Okay. So, this each length, so we have to define, we have to calibrate basically with your data. If your data is in mass, is in gram. Okay. So, data is there from 0 gram to say 1000 gram. Okay. So, here on the graph paper, so you have to say, you have to consider one line. So, this we take axis. So, this horizontal line, one line we will take as a axis, that is x axis, and to representing the dependent variable. So, x axis, along the x axis generally we plot independent variable, and along the vertical axis, that is called y axis. So, we will take a line. So, that is y axis. Now, that axis will scale with some dependent variable. Okay. So, that dependent variable, it depends on the x. If x varies, so x and y have relation. So, y will, from that relation we will get the value of y. So, that is dependent variable, it depends on x. So, that x will plot along the horizontal line, that is x axis, and the dependent variable that will plot along the vertical axis. So, that is basically y axis, right. So, rule is that you have to choose the length of x axis and y axis in such a way that it should be 75 to 80% of the total area or length and width of the graph. Okay. So, reason is that you can show your data clearly. Your data should be distributed over the 75 to 80% of the area of the graph. Okay. So, basically main reason for that you are enhancing the representation, or you are magnifying the representation of your data if you choose very small area, x axis length and y axis length is small, and then you are plotting your graph, then what will happen? So, that scale, say as for example, I told that 0 to 1000 gram. So, this if you scale with the length of here with 2 box, bigger box, okay, 2 bigger box, 0 to 1000. So, your data in between 100, 200, 500, 700 etc. you are plotting. So, that will be within this range. Now, if you choose 10 box for 0 to 1000 gram, so that means you are basically magnifying your plot. So, same data you are plotting in magnified way. So, you can represent well, and that will be interpolation, extrapolation, that will be easy. What is interpolation, what is extrapolation, that I will discuss. So, you can, so visibility will be enhanced. Okay. So, that is the reason why we tell that at least you should use 75 to 80% area of the graph paper for your data plotting. Okay. So, as I told that if you just choose 2 box for, it is not necessary it will be rectangular. So, you may choose this here 2 box, here 1 box. Okay. So, here you are representing your, so this basically one. So, this is the total area you are using for your plotting graph. So, your plotting graph here this way. Okay. So, you are using this portion of the graph only for representing your data. Okay. Instead of that, if you use this larger area, say larger area for plotting graph, the same data, okay, you are plotting. So, this your data is say okay, like this. So, average data you are taking, average plot you are taking, drawing line, average line you are drawing. So, for same data, now here with the smaller graph, what is the deviation of your data point, that whatever the visibility here, deviation from this line, average line you have drawn, what is the deviation here, whatever the you are seeing here, the same deviation here you can see this deviation, it looks very prominent, and so it will help you if you use bigger area. it will help you to find out the deviation from the average curve of your data points more accurately, because here you have to count, basically here you have to count this what is the deviation, right. So, from scale you have to find out this is the deviation. So, here this you will get more accurately, because more number of this small square box you can count here, and that that value, okay, it will be more accurate than this one, because here scale this it is again this like least count. Okay. So, here least count is higher. For least count, in this case we will consider as a this smaller box. What is the smaller box? That is x axis scale and y axis scale. If it is 1000, so within these two, so basically if you use two box, so your each box value 0 to 1000 means here 10 boxes are there, 10 boxes are there. So, that means each box value will be 100 gram, whereas here if you take 10, each box value will be 10 gram. Okay. So, here this least count will be 10 gram, whereas in this case least count will be 100 gram. So, you know this if least count is smaller, so that is better. Okay. So, your error will be lower. So, this is the reason we tell that you should use higher area, larger area of the graph paper to represent your data. So, this is the reason why you should use 75 to 80% area of the graph paper for plotting your data. Second, now how you will scale this your x axis and y axis, right. So, you have to look your data. So, because you have 2 column data, say, so one is dependent variable and another is independent variable. So, independent variable, what is the range of the data? Say, as I told that, as per example, that you are measuring weight, and for that weight what is the, say, some parameter frequency. Frequency depends on this mass. Okay. So, frequency is a function of mass, frequency is a function of mass. Okay. So, basically you have 2 column data, then you have 2 column data, you are changing mass and measuring the frequency. Okay. So, mass it is in gram, frequency it is in hertz. Okay. So, you have data 0, say 10, 20, etc., and corresponding frequency, say 100, 200, 300, etc. Okay. So, it is, so you have to as I told, when you will collect data, so you should mention the unit in the table, and this also you should use the unit, that is a gram. Okay. Now, here I have to say up to 1000 gram it is there, and this frequency it is up to 2000 hertz it is there. Okay. So, your range is for mass 0 to 1000. So, your x axis that you have to scale, so this starting from 0 and ending will be 1000. Okay. So, how many boxes are there? First you consider the bigger boxes. Now, in each bigger boxes you have the 5 division. Okay. So, smallest division is here is the basically smallest box. So, here 1, 2, 3, 4, 5, 6, 7, 8, 9, up to it is 9 is there, up to it is 9 is there. So, up to 9. Okay. So, you have to consider this up to 9. So, this 1000. So, that is slightly inconvenient. So, if you have so I could shift this one here, origin I should shift here. So, then I will have 10 boxes. So, 10 boxes corresponding 1000 gram. Okay. So, each box is basically 100 gram, and now in 100 gram in each box there are 5 division 1, 2, 3, 4, 5. So, each smallest box will be then 10 gram. Okay. So, that you have to define one smallest division, in x axis equal to 10 gram. Okay. Similarly, one smallest division in y axis equal to, you have to define. So, this is a 2000. So, if it is also it is 10, if it is also 10, so then basically it will be 20 hertz, it will be 20 hertz. Okay. Now, from your data, if it is 10 gram, so it will be just one box, it will be just. So, I have to shift this like this. Okay. So, this is 10 and hertz is 100, that means I have to go 5 division 1, 2, 3, 4, 5. So, make it circle. Okay. Same way you just plot other data, you just plot other data. Okay. So, and then after plotting, so you have to draw an average curve, So, here I have drawn just one line. So, it can be curve also, it may not be linear curve, it may be non-linear curve. Okay, depending your data, depending your theoretical knowledge, whatever the dependence of y and x, what is the relation between y and x. In this case, frequency is related with the mass m with some constant, or it is a square of mass, it depends on square of mass. So, depending on that this curve. So, if you have this knowledge, so it is easy to draw graph. So, basically we do not draw the graph this just connecting the point, this way zigzag, this way we do not plot, we plot this average curve. So, and then consider the points are deviated from this from this average curve, and that deviation of upper side and lower side is the it is a minus and upper side is the plus. So, it should be this your plus minus, it should be more or less total plus and total minus, that is a deviation, it should be 0. Okay. So, that means plus deviation and minus deviation should be same. So, that way one has to draw this curve, and there are some least count fitting. So, this is basically line graph. Okay. So, line graph, bar graph and pie graph. So, these 3 types. So, among them, so this line graph is very frequently we use in lab. So, we will discuss about this line graph more, and how after plotting graph, how we can extract information from that graph. So, that I will discuss, and every time as I told the how to choose the scale along the x axis and y axis, and then you have to level the x axis. So, in this case you have to write mass, right, you have to mass in bracket in gram. Y axis you have to write frequency, in bracket you have to write in hertz. Okay. So, without seeing your this table, one should understand everything from your graph. Okay. So, if you plot this way, so these people will know that okay, along the x axis. So, what is the value of this point? So, one can find out. So, from here you see okay, each smallest division is 10 gram. So, how many these points say along the x axis, how many boxes are there. So, bigger boxes 1, 2, 3, this 4 means 4 into 5, this 20 box, smallest box, and then I think it is 1 and then 21, 22, it is 21.5. So, this 21.5 into 10 gram. So, 21 means 210. So, it will be 200. So, multiply with 10, 21.5 215. So, this value x axis it will be 215 gram. This point is 215 x along the x, this x value, and y value you have to count here. So, here smallest division is 20 hertz. How many are there? 1, 2, 3, and this is 3 means 15, and this is 4. So, 19. So, 19 into 20 it is 380. So, it will be 380. So, 380. So, the value of this one is 215 gram and 380 hertz. So, all information should be on this graph, and anyone can see and find out the value of this any points on this graph. Okay. Now, after plotting the points, so why we need to draw a average line or average curve. So, this is basically you have taken data, it is a discrete data, it is not continuous data. So, what will be the value between two points, whatever you have taken data, these 2 points, okay, it is giving 2 points. Now, in between what will be the value for, so what will be the other value. So, for other masses what will be the, so that experimentally you have not find out. So, but from graph if you just draw a average curve, now from that curve, now that will give you in between this value. Okay. So, this basically it is and it is not exactly extrapolation, it is basically this point is no more this is the experimental value. Now, average on average curve this is the value, on average curve this one actually this is the value. So, if you connect this point, so in between other points you will get, it is not found experimentally, but from the graph other point you can find out. So, this is the interpolation, it is called interpolation, and if you want to find out the beyond this whatever experimental maximum this one, beyond this what is the value. So, these are called the extrapolation, this side it can be this other side also. Okay. So, these are called the extrapolation, interpolation between 2 points, what are the other points. So, if you connect them you will get the other points. If you so interpolation, and beyond this your data, if you want to know the values, so then you have to extrapolate. So, that is the called extrapolation. Okay. This can be this side or it can be this other side. Okay. Interpolation and extrapolation. So, it is because in your instrument it is beyond, you cannot measure beyond this point. So, but if you plot graph, then from that graph you can find out the other higher side and lower side other points, which you are not able to measure using your instrument, because that is the limitation of the instruments. Okay. So, graph will help you to get these other points, okay, which experimentally was not available. So, I think I will stop it and continue in next class. Thank you.